Hello students, welcome to my YouTube channel. This is class 10 of lesson AC currents. Hope the previous sessions what I have held in this lesson, all of you have understood. So any doubts is there, please update me through WhatsApp. So in the current session I will discuss with a topic called transformer. So before going to the concept, let us have some examples where a transformer can be used. Let us take a basic example as mobile charger, where you are inserting the charger to a 240 volts AC, where the output is 5 volts DC. Now the question is how you can reduce the voltage from 240 to 5, and thereafter how you can convert AC to DC. There are two things will be involved in charging of a mobile. Now in the current session I will discuss only how you can reduce the AC voltage. Later, the conversion of AC to DC is a different lesson known as rectification. That concept will come in semiconductor electronics. Now, let us discuss first of all what is a transformer. Transformer is a device which is used to alter AC voltage. By either decreasing or increasing the current. So, to understand that, let me repeat the definition. A transformer is a device which is used to alter AC voltage, keeping power constant. So, first of all, what is the power formula? Just recall. Power is a product of voltage and current. So, across any transformer, if you see, the power will remain same. But only thing is, you can alter voltage by altering what? Current. See, if power is constant, just try to imagine the formula. If power is constant here, if voltage is increased, what happens to the current? It decreases. If voltage is decreased, what happens to the current? It increases. So, keeping power constant, voltage can be altered by changing the value of current. Such phenomena, if a device is performing, such device is known as transformer. Now, transformer works on what principle first of all? It works on the principle of mutual inductance. So why I am taking beginning itself means mutual inductance takes place only when there is a pair of coils available. You know, in lesson EMI, self-inductance and mutual inductance I discussed. So same concept will come here. So just I will draw first of all basic symbol of the transformer. From that I will make you to understand how a transformer works. See, so this is a basic symbol of the transformer. One coil is called as primary coil, the other coil is called as secondary coil. Now, why this symbol is used? So the symbol itself indicates there are two coils are available, and how these two coils works means based on the mutual inductance. And based on mutual inductance, how we can vary the voltage that I discussed when the construction comes. So, as a recall, transformer is a device which is used to alter AC voltage. It never converts AC to DC. So, try to remind, it just decreases or increases the AC voltage by changing the current. At the same time, it maintains the power as constant. Now, what is the principle of mutual inductance? Important in 1 mark category. It works on the principle of mutual inductance. Now, what is the symbol of transformer? This is the symbol. Now, in this, how mutual inductance will work? For that, let us start getting the construction of the transformer. See, I am drawing here only the basic block diagram. It's not actual diagram. You can find transformers in daily life if you meet any electrical technician whose person repairs television sets or somewhere electrical appliances. If you ask them, they will give you a transformer. So you can see the construction. If not, I will try to upload the actual image of a transformer. See, this is a block diagram of the transformer. So one side coil is known as primary coil. See, this is again I am telling it's a block diagram. Typical transformer, if you take, that looks different from this. Here I have shown the coils in separate positions. but in actual transformers, coils will wound one over the another. Okay, so let us go with the construction first. A transformer generally consists of a laminated core. The core is generally used to mount the coils. Generally, they use hard plastic. In some people, they use metallic sheets, E-type metallic sheets that I will show you the diagrams. So, a core initially they will develop using certain hard material, over which they'll start winding secondary coil first. Sometimes they use primary coil also, depending upon the situation. But generally, in order to not to lose magnetic flux, they use primary coil and secondary coil. So try to understand. First, they wind one coil. The coil is generally made up of insulated copper wire. You know what is insulated? It's a copper wire generally, where over the insulation coating will be there. This concept I discussed in self-inductance. When a solenoid is prepared, how to prepare a solenoid that I discussed in detail. So same like copper wire which is having insulation coating is used as one secondary coil. So each coil will have two terminals. Assume these are the two terminals. One secondary coil is winded, over which they will wind primary coil. That is a different coil. So each coil will have two turns. So I am telling the construction of a simple transformer where one input and one output. There are transformers available with multiple outputs that I discussed at the last. So, in the using of insulated copper wire, they will construct a transformer with the help of primary and secondary coils. Here, one thing is confirmed. There is no transformer having equal number of turns in the primary as well as secondary. There is no such use at all. But what happens? Based on the working function of transformers, there are two types of transformers are there. One is known as step-up transformer. The second is known as step-down transformer. Hope these two things are got in your lower standards. What is step-up? See, you can imagine this way. As in this is steps. This is not step-up. Just for the understanding secondary. What is step-down? This is step-down. So here, initially you take it as primary, the second one is not secondary. Again here primary, here secondary. Step up means you are going lower primary level to higher secondary. I mean, primary coil will have less voltage than that of the secondary. Whereas in step down, primary will have more voltage than that of the secondary. So here, in order to increase the voltage, see, always primary takes the input and secondary gives the output. So here, input voltage must be less than output. So you are supposed to get here output voltage more. In order to get more output voltage, simple rule is increase the number of turns. The reason is, as per the mutual inductance formula or concept, when a current passes through one coil, there is a change in the magnetic flux takes place. Since it's an AC current, that magnetic flux acts in the other coil and will produce an EMF. So you can recall the definition of mutual inductance. The phenomenon of inducing EMF in one coil due to change in the magnetic flux linked with the other coil. So this magnetic flux, where it develops in the primary, will act over the secondary, and here EMF will produce. That EMF will take as an output. So there one rule I told. EMF developed depends upon two things. How much input voltage you are giving. The second depends upon the number of turns. So simple rule. Keeping the voltage constant here, keeping the magnetic flux constant. If you increase the number of turns, automatically there is a change in the voltage. Means turns are more voltage. Turns are less voltage. That is a simple concept. So, in order to construct a step-up transformer, construct in such a way that secondary turns are more than that of the primary. To construct a step-down transformer, so you are supposed to get less voltage. Then automatically what is the rule? Vice versa. Decrease the number of turns in secondary than the primary. So this is a simple rule. So Using step up and step down mechanism, they'll construct different kinds of transformers. So let us get back to the construction once again. So transformer consists of a core, laminated core, over which insulated copper wire is wound as primary as secondary coils. Now, what is the working function? Primary coil will take the input voltage. So as per mutual inductance, when AC voltage is supplied to the primary coil, since AC voltage is not constant, magnetic flux also is not constant. Its flux will vary. That variable flux acts over the secondary coil. Since the flux is varied, that induces an EMF. So here one thing you are supposed to keep in mind. When there is a change in the magnetic flux, then only EMF will be induced. Constant magnetic flux will not produce EMF as per the Faraday's laws. So, I repeat, when AC voltage is given, since the voltage is variable, it produces a magnetic flux also in variable manner. Such variable magnetic flux act over the secondary coil and causes an EMF. That EMF will be taken as an output. So this is a simple way of working of a transformer. So here if you want to require low output voltage, simple, decrease the number of turns so that compared to the input voltage, output voltage will be less. Then the transformer is treated as step down. If you want more output voltage, simple, increase the number of turns. Then compared to the input voltage, output voltage will be more. Then that is called step up transformer. So hope you understood about the concept of the transformer. I repeat, what is a transformer? A device which is used to alter AC voltage. And how we can alter AC voltage? Keeping power constant, either by increasing or decreasing the current. Then, what is a diagram? Basic symbol of a transformer. This is a symbol, important one marking. What principle does it works? Based on mutual inductance. Now, how many types of transformers? Two types, step up and step down. What happens in step up? Output voltage will be more than input voltage. What is step down? Output voltage is less than the input voltage. So what is the construction? I expect using laminated core, there will be two windings of the coils using of a laminated wire or insulated wire. One is secondary coil, the other is primary coil, but there is no equal number of turns. Either the number of turns in secondary will be more than primary or less than the primary. Less than the primary is called step down, more than the primary is called step up. Now construction of working function, when input voltage is given, due to change in the voltage, mutual inductance takes place, change in the magnetic flux takes place. Such change in flux acts on the secondary and that leads to produce of EMF. And that EMF is taken as output. But keep in mind, whatever the EMF you will get here also is an AC type, not DC. Further, that decreased AC voltage is used, like we can say, is fed up, means it is given to diode as an input in order to convert to DC. That mechanism is called rectification. That is out of syllabus as per the system. Now, let us have some mathematical expressions. So here, the voltage produced or voltage given or voltage taken, anything you get it, is directly proportional to number of turns. So using this formula, voltage in primary is directly proportional to number of turns in primary. Similarly, voltage in secondary is directly proportional to number of turns in secondary. So if you remove the proportionality, you will get some constant. Let's say constant is known as T here for convenience. Now I can write as Vp is equal to Np, that constant is equal to 1 timing, and Vs is equal to Ns. Now take these two equations. See, you take Vs by Vp, equation 2 by 1, and that is equal to Ns by Np. LHS by LHS, RHS by RHS. and this will be equal to a constant known as T, where T stands for turns ratio. T stands for turns ratio. What does it represent? Using the turns ratio, you can decide whether a transformer is a step up or step down. How? Just for the clarification. If turns ratio is greater than 1, take a simple concept. If T is greater than 1. T is greater than 1 only if number of turns in secondary is more than number of turns in primary. Because to get more than 1, numerator must be more than denominator. So here numerator is more means number of turns in secondary more, number of turns in primary less. Turns is being more, then that will be treated as step up. Again, T is less. Numerator must be less than denominator, then that leads to step down. A simple way to understand how the turns ratio is used to indicate whether transformer is a step up or step down. Now, what I said, power will remain constant. So, power is equal to volt into current. Now the question is, if you take primary power as voltage in the primary into current in the primary. Similarly, I am applying the same formula for secondary current. Voltage in the secondary into current in the secondary. Since power remains constant as per the definition, these two can be equated. Vp into Ip, that is equal to Vs into Is. So take the like terms on side. Vp by Vs, that is equal to Is by Ip. So that thing and substitute. Since Vs by Vp, if you take it reciprocal, this term will get. So this formula can extend as Vs by Vp, that is equal to Ns by Np. Since it's a reverse of this fraction, even this also get reversed. I can write as It by Is, that is equal to T, which is the basic formula of the transformer. So from this, what is used? If you know the turns ratio, or if you know the voltages, you can calculate the currents ratio. Or if you know any, see here you have all 6 variables. Take two fractions as a combination. Among the first combination, if you have 3 variables, you can find out the fourth. Let's say for example, they'll give the voltage of secondary, voltage of primary, and they'll give number of turns in primary. They'll ask to calculate how many turns are there in secondary coil. You can calculate. Similarly, by giving the number of turns, they will ask to calculate the current in the primary by giving current in the secondary. Or they will ask to calculate the turns ratio. Anything you can calculate. So at the last, what is the efficiency of a transformer? Efficiency symbol, you know, it's eta. From thermodynamics, you got a symbol, it's the same symbol I am using. So efficiency is equal to output power divided by input power. Generally, as per the statement, power is being constant, efficiency of the transformer must be equal to 1, because input power is given to the primary and output power is given to the secondary. Then, as per the definition, if you take the ratio is being same, efficiency must be equal to 1. Then, how to define efficiency? Efficiency of a transformer is the ratio between the output power to the input power. But if you see in real time, for instance, in daily practice, no transformer gives efficiency is equal to 1. Why is the question mark? Why the efficiency will be always less than 1? The reason is there is some kind of energy losses takes place in the transformer due to its construction mechanism and due to certain principles. And what are those energy losses? How many kinds are there? And how they will occur? And how to minimize it? That I will discuss in the next session. So hope what is a transformer you understood. So as a recall, definition is important, principle is important, and symbol is the most important things. And this formula is used in the numerical cases. And based on this, you may get objective questions. Like if transformer has turns ratio greater than 1, it could be what? Step up. If it is less than 1, step down. Now you can understand why there is no equal number of turns. There is no use, because in order to alter the AC voltage, there must be difference in the turns. Without difference in the turns, there is no any transformer. Or simply, you never find a transformer having equal number of turns in primary, equal turns in the secondary. Hope you understood the concept. So in the next session, I will discuss about energy losses in the transformers and how to minimize it. Those concepts I will discuss. With that, your lesson will get done. So thank you for the session.